Hi, and welcome to the second session of Academic Crisis Line. I'm super excited today with the first time with guests, Stephen Weissberg, who is a member of my lab at the Chatlab at Upenn, and Giulia Frazetta, who is GitHub specialist and research specialist at Geoffrey Aguirre's lab, also at Upenn. So before we start with the actual content, today we're talking about archiving and documentation. Just very briefly, if you're asking questions, or if you have questions, please ask them right away, because there is a tiny delay in the live stream. So it's actually getting a bit awkward to wait until you're ready to type the questions, and we're waiting here for your questions. So just type them right away, and we will answer them as soon as they pop up. If you want to ask questions, you can either use the chat function on the right on the YouTube screen, or you can live tweet to @phdial. So far, so good. So the most important thing, I think, when it's about keeping a good documentation and keeping a good overview over your files and everything you're using, is keeping your desktop and file structure tidy. It's very important to keep things which belong together in the same folder. And I find it most useful to use project folders, which have the same subfolder structure. As soon as you have more than one experiment, it's going to be super annoying that all your log files and output files have the same name, and you just have de-identified subject information. So it's going to be a hell to figure out which belongs to which. So from the beginning on, just keep everything in the same file. So I now show you how I do it. So this is my desktop, and here we have my Finder windows. So I have one folder in Documents, which contains all bigger chunks of information I want to share, and everything which belongs together is in the same folder. So I have a Data folder, there are projects where I'm currently working on analyzing, and there are also raw folders where I archive my data. I have a Graphics folder where I save all funny or interesting pictures which might help to make my talks a bit more exciting. I have a Literature folder where I dump all the papers I need, and this is synced with my Dropbox as well as with my Mendeley account. I have a MATLAB folder which contains all the projects for which I'm using MATLAB to analyze. I have a folder where all my presentations are, and then most importantly, my projects folder. They are all projects with the names I gave them, and all have similar structure. They have materials, they have data, they have figures, everything I need. But very importantly, I never mix them up. So every file I'm analyzing or I'm writing goes into these, apart from the actual writing. The actual writing, for me, goes in my writing folder, where I have the same project names as I have in the projects folder where all the material for the study is. But here goes everything from papers, manuscripts, abstracts, figures for papers. And as soon as I start a new project, I'm opening a manuscript file, which goes into this. And in this, even if I haven't written anything from the introduction or anything, I right away write up my methods. This saves me a lot of work for writing up what I did, how the analysis did go. So you see, I haven't written a word for the introduction yet, but actually I've written up all the methods, and as soon as I finished analyzing the results, this is going to get here. So this is how I avoid doing additional work. So now I think this is the most important part. One really big don't is avoid redundancy and have too much of a mess in the folders. Save everything at important steps in the analysis and the process, but delete everything else. This makes it much easier to find important things. And a very similar and helpful tool for actually publishing this is Open Science Framework. It's very similar to the folder structure here, but this is where you get the most tidy version, And I think Stephen is going to talk about this now. So I'm going to stop my screen share for a bit so that he can talk. Here we go.
Okay. So that's a great introduction to one way, or a great way to organize your files locally. But when it comes to sharing those files with other people, it's important to keep them organized and also to make them available publicly on the web where they'll live. One tool that's been developed recently in order to do that is the Open Science Framework. So I should start by saying that I'm not the expert on the topic. I've used it a few times, and I've found it to be useful for particular aspects of my scientific workflow. So one thing that I've linked to on my Twitter is this Google Doc here. I'll cover that in a second. It has some useful links, the Open Science Framework support and guides, as well as their Twitter. They're really active on Twitter. You can also look at the one project that I have made public on Open Science Framework. And before I go through this, I'll show you just a little bit about how it looks. So Open Science Framework allows you to create your own profile and to create your own projects within that you can then share with your collaborators. So it makes it a really useful way to not just have your own local files that you work on, but also be able to share those files with your collaborators, and so they can work on them too. So just to give you an example what a project looks like, there's a lot of aspects and a lot of things that you can do. Two of the most useful things I think that the Open Science Framework provides, in addition to sharing with your collaborators, is it allows you to store basically your entire project files, everything that you would need to recreate that study, experiment, whatever, in one place. So this is a project that I just recently published. It has a name that's tied to the name of the paper. Open Science Framework also allows you to version everything. So it gives you a DOI that you can cite, that you can share, and that serves as a sort of public record of your project in addition to the paper. It allows you to link in storage. So here I have my GitHub account with some of the code and the data. It also has its own OSF storage, which you can use not just for backup, but for versioning. So here's the data that you would use to recreate the analyses from the paper. And here are some of the materials that were important for analyzing the data or for coding the data. You could also post questionnaires. You could post anything you want. So OSF allows you to sync with GitHub and a number of other different features. It allows you to tag your project, and there's a lot of other organizational features. This gets more complex. You can add multiple studies. You can nest projects. And then the other important thing that you can do, which I did not do for this project, but it allows really easy registration. So I know pre-registration is not the topic of today's PH Dial, but you can see here is a project that's a much simpler setup. So I've only had a few different data files and a couple of documents that are pre-registration documents. But what I've done is create an embargo pre-registration for them, which basically means it's a time-stamped DOI that is the exact data and the exact pre-registration document that I used at that time to serve as a pre-registration. So the Open Science Framework is really useful for that as well. And as you can see, it provides a little citation that you can link to and put on your CV. So briefly, I'll cover some do's and don'ts. If you do use OSF, it's really helpful if you plan to use OSF from the beginning, if possible. If you're using Francisca's file organization structure, then it makes this a lot easier. But don't worry about making everything public. Think of OSF as your public-facing version of your project that someone else is going to use. So don't make it messy, definitely on OSF. You can be messy locally, but try not to be. Do use OSF as an archive and a backup, which includes versioning. Do pre-register your study design and materials if it's appropriate, but don't feel like you have to pre-register everything to use OSF. Do keep everything organized and labeled. Again, this is not just for you. It's open science now. It's for everyone. And if you don't back up your data on OSF, definitely back it up somewhere. I can't stress that enough in my own stuff. And finally, don't forget to cite your data and use your DOIs. If you have any questions, you can direct them to me on Twitter or at the PH Dial live stream.
I have a quick question.
Yeah.
What are good points in time on a project timeline when to put things online?
So I would say there are two different answers to that. The first is if you're planning on using OSF, it's best to do it from the beginning. It's just easier to organize everything and back everything up if you're sort of planning on organizing everything that way. But that said, I think the second best time to do it is to archive everything that you used for a project.
Mm-hmm.
So once that project is, maybe you just submitted the paper, all the data are finalized, all the analysis scripts are finalized,
mm-hmm.
That's a great time to put everything on OSF and have that live as the sort of version of your data and materials that go with a paper.
Mm-hmm. Thank you.
Mm-hmm.
So let's quickly check. The Google Hangout screen. So, thank you, Steve, for talking about OSF, and now Giulia will tell us about GitHub use.
Hello, everyone. I'm Giulia, and I was asked as an enthusiast user of GitHub to tell a little bit more about how it works and why it could be either a very useful thing or a very, very life-saving one, because GitHub has the one purpose of keeping track of you writing and editing and adding new code to a project. So my own definition for, well, it's not my own, but I like to think of it as a versioning tool as opposed to an archiving tool, because I see the code as a dynamic entity. And especially if you're developing a toolbox, which is something I do a lot in my role in the lab, it's something that you know from the start is going to evolve and is going to be used in several projects, and every project might need a little bit of code in addition to what's already there to make it work better or to make it customized. And GitHub is helpful because it releases you to the duty of having folders and folders and folders and making sure that the code has the proper name. And what if you need to go back to a project of 2 years ago and you want to have the same results, but your code base has evolved since there? Well, GitHub will keep the code there for you. And if you're working on your own or are writing code with other people, which also happens a lot, you always have the tag and the log of exactly what happened and who did what on the code you're working on. So again, I'm a very enthusiastic user of GitHub. I am not an expert, but my idea is now to show you my profile and the code repository that I'm working on in the lab, to show you how it works and to go through the very, very basic on how this famous repository in GitHub work. Also, for the records, GitHub is not the only tool that you can use to version your code. There are a lot of other similar services. Someone uses Bitbucket or well, there are a lot, and there are a lot of tools that you can use offline to do that too. I just use GitHub because my lab does it, and I find it very convenient for a reason of way that I will now show you via the screen share. So there we go. Now, this is GitHub, and this is my homepage on GitHub. Once you create an account on GitHub, you will have a profile page which will look like this as soon as you start following people in a very social manner, like everything it is now. And it will provide you a feed with what your friends or people you're following on GitHub are doing. Also, it will provide you a list of the repository you are contributing to, and also a list of what of the repository you are interested in or you are watching. As soon as you're linked to an organization, as I am, you will also have the opportunity to look into your organization tab. In this case, this is the GitHub account for my lab, and it's a feed on what's going on in the lab and in the repos for the lab. So this is just a general overview. And of course, being kind of a social thing, you also have a profile where you can look at your stats. You can add a bio, which I didn't do yet, and where you work. And you have a nice, funny display of what you've done so far. And as you can probably guess from here, I work on the GitHub a lot, and I make sure that every single line of code I write ends on GitHub almost the moment I write it. Well, let's say the moment I'm sure about it. Now, if you have a free account, as I do, every little bit of code you put up on GitHub is going to be public. That doesn't mean that it's not yours anymore, and this is very important, and I'm not going to be stressing this enough. The moment you put up a code on GitHub, that code is timestamped and is linked to you as an author. So even though it's public, that code is still yours. The fact that it's public might have some side effect if you wanted to, I don't know, patent a method or something. But as far as research is concerned, it's often enough to have the attribution of the code. But again, I'm stressing it, if you want to keep your code versioned and private, you might want to consider get a paid account. If privacy of the code is not an issue, you are probably good with a free account. Let's see how a repo works. So this is a toolbox I'm working on. And this is how any GitHub repo looks online. You should have a README file that explains what this repo is about. This specific one is about eye tracking. So it will have a description of what the repo does. I recommend putting down some ideas as soon as you start the repo and then working on improving this file as soon as you have new function in, because it both helps you tracking things and keeping it tidy and keeping an idea of what are your goals. Pretty much as every other aspect in research, I guess. Then you have your own code, which in this case is MATLAB code, that you can sort and distribute in folder. This is not a standard thing. This is the way I organize code. You can add a license right away, and then you can do your own coding folders as you usually do. The way I do it, I try always to put in a demos in the code as soon as I have something working with files readily available, especially if you're trying to share the code. It's a very good practice to put a easy and lightweight demo to show people how it works, especially, again, if you're sharing. And then these are normal MATLAB function. It's exactly the code that you have on your computer. The nice thing about having the code up here is that for every function like this, you have a history, which will tell you what kind of edits have happened within this function. This specific one had 29 changes, and these are the changes that happened. And I will have you note that I'm working on this repo with my PI here, and we are both editing functions back and forth. Now, if any of you has ever coded with someone else, you know how hard that could be. Like, you leave at night, come back the next morning, a variable is not called as it was yesterday, and nothing on your end works anymore. That's dangerous for various reasons, not the least one being like the well-being of all the people working on the code, except for the code itself. So every single commit, and I will go into the specific language of the code in a second, has a name on it. So we did more than 500 edits here. And if you keep your tabs correctly, if you upload every single edit you do, every single edit will have your name on, and will have a small description of what was done in the edit. You can be, according to the edit, it can be like a long description, a short description, just a title. I recommend as the code base grows to add a more detailed description so that you know exactly what happened, where it happened. Now, let's go into the specifics. So if you're working on your own, this could be exactly all that you need to know. Keep in mind that your code will be public, so I do encourage you to be tidy, which you should always be with code anyways, because code is probably one of those things like handwriting. If you can't read your own handwriting, well, it can be complicated, not even going too far in the future. Code is supposed to be optimized and be consistent with variable naming, no matter what language are you using. It could be MATLAB, Python, Ruby. Be consistent from one function to the other and from possibly one project to the other. If you have a folder called data in one project, or output or figure, maybe you want to have the same structure over again. If you are sharing the code in public, I hope you are more self-aware about your appearance of the code. So give meaningful names, comment a lot. I won't stress it enough. Even if it's just for yourself, comment your code. And if you're not sure how to explain something or how to explain a passage, add that comment, especially in non-official version of the code. Add notes to yourself if you need so. And if you are willing to do a little bit of experimentation, GitHub will allow you to do so without risking to break the code. And I will show you how in a second. Let's go back to the main page of this repo. So as a default, when you click on any repo that's online, you'll be in what is called the master branch. Now, the master branch is the official current version of the code that you are writing. It means that when you start a new repository, every change you make goes into the master branch. After a while, hopefully, you will have a master branch with a little bit of code that it's working. Whenever you want to try something new, you maybe don't want to risk to break what is working already. So what you can do is you can make a development branch, which will effectively copy your code into a separate folder, and in which you can make all the edits you want to make to the code. Now, if I go and see the structure, let's see. If I click on this branch, you will see in the link up here that here I am in geometry development branch. I'm not in the master branch anymore. Any change I make here will be living separate from the main code, both online and offline. If you download any GitHub management tool offline, you will see that you can switch between branches exactly as I'm doing here. Now I'm in my master branch, and now I can switch, and I will be in my dev branch. I do recommend to get an offline tool because it works better. But if you don't, you can always download the zip code of the branch you care about. and or open into the desktop with however you are comfortable with. If you use the command clone, you will have also the ability to put the tracking tool back. And if you're using MATLAB, MATLAB has inbuilt versioning tools that are compatible with GitHub. So you don't, in principle, you don't even need to have an offline tool to make this work. And this is just for working on your own. I will show you now how it works to start a new repo. And that's very easy, like clicking a button, and I will do it on my own account. I have the possibility to do it on the GitHub, on the lab account. This is a test repo, so I will do it on my own account. First thing, you have to define a repo name, and we will call this phdial. A description, I recommend using it. You can change it at any time. This is a test repo. If you want to make it private, you need to have a paid account. We can make it public. First thing, I add a README. It's going to be empty. And I can choose to add a license. Any license I want to add, it's here. We're going to add this license. And I create the repository. There we go. Now I have my README file, which contains the information I added before. And I have the license file that GitHub provides automatically. That's also very useful if you're like trying to write code that you want to publish later on. There you go. Once you do that, you can either download or clone the repo and use it offline. And the moment you have code to put on, you can upload it again like this. You can do it all by the web interface. I do not recommend it, but it's doable. You can choose files and add the comments of what you've done. I'm gonna just add any random file which I found on Francisca's desktop. I hope it's nothing too bad. Francisca, where should we go?
You want some code?
Yeah, any function would work.
I don't see my desktop here. So it doesn't give me, maybe this is the
Documents. There you go.
So what we could do, for example, is the R code of Tim's or Tom's.
Okay. So here I have some R code. We have some R code, and I will make a commit, which means I am sharing this code online, and I will add a title. This is some R code for Tim or Tom. And I will add a description if I need to. This is a test upload to show how to make commits. I can decide whether I want to be brave and put it on the master branch, or maybe put it on another branch, which we will do and call development. And this is it. Now, if I am sure, there you go. This is the code. In green, you see everything that's new in the code, which in this case is everything. And how many files we change, which in this case is 1. Now, if I go back on my main page for the repo here, in my master branch, I of course won't see the file. But if I go in my dev branch, here it is. Now, if I'm sure that this file will work and I'm ready to share it in the official version of the code, I can do what it's called a pull request, which is here. And this means that in this case, I am asking myself permission to use this bit of code in the official version of the repository. Of course, when you're working on your own, this is kind of trivial, but if you have people working with you, or if you're sharing the code that someone outside in the world is kind enough to find the bug and correct it for you, you want to review what they did. In this case, I'm just going to create a pull request, which is actually a request to merge these changes into the official version of the code. And GitHub will also check for you if this can be done safely. In this case, it can, because what I edited has no conflicts with what's already there. And the moment I do this, I will have the code up in the official version. There you go. Now it's here.
I have a question.
Sure.
Are both the development branch as well as the master branch public?
Mm-hmm.
Okay.
They are both public, and that's good because, well, you can make it private if you have a paid account, I guess, but they are both public and they are both people can see them from everywhere.
Mm-hmm.
And something very nice that happened a while ago in the lab is that we got actually a pull request for someone outside the lab, which was super nice. So if I look at pull requests and I look at the closed one, we have Nathan, that it's another guy working here at Penn, that it's using this repo hub here that we developed for pre-processing of the MRI data that found a bug in the function that we were using to process the PulseOx information file. So he fixed the bug and asked us to merge his fix. So this is Nathan's account writing to us, hey, I found a bug and I fixed it. And this is Jeff, my PI, thanking him for the edit. And we went on for a little bit in a conversation on the repo itself to discuss if the edit was actually a good one. And everyone of the lab, even members that used to work in the lab and were familiar with the repo here, contributed their view and their comments about the edits that Nathan did for us.
Mm-hmm.
Eventually, we found out that they were very good edits, and I was able to merge the commits. So that's a happy ending story, and the demonstration that if you share the code, something good is likely to happen more than something bad. If, like, for once, you're gonna be tidier on your code because it's up for like, no one is gonna stalk you line by line. But if you have someone that is likely to read your code, you want to make sure that the code is right.
Do you also upload data, and do you recommend it?
Not on GitHub, absolutely not. Not on GitHub. No, I don't even update the demo data for my demo function there. That's because GitHub is not the best place. You're limited in space, and if you start filling it with data, it's gonna fill up pretty quickly.
Mm-hmm.
And it's out of the purposes of GitHub itself. So for my demos, I do update the data on Figshare, but Open Science Framework would work exactly the same. And you can add links to your demo on your data on the GitHub repo itself, but I wouldn't recommend to use it to upload the data.
Mm-hmm. So if you upload your data to the file repository and you use GitHub to share the code with which you analyze it,
Mm-hmm.
and you're doing this before the manuscript you're working on has been published, are you worried about getting scooped?
I wouldn't, because my name is there, and a timestamp for every single bit of code that's in this repo is Superhold, for instance. We started working on it more than 2 years ago. But every single commit is time-stamped.
So you basically have your patent on it.
Yeah, you have your authorship attribute to every single bit of code.
Does GitHub offer an official copyright?
I guess it does. I should look into it, but I don't see why not. It is used at the industry and commercial level to keep track of code, so I guess it does. It's not just for open source code, it is used to version protected code. That's why you can have protected repos. So I would think that it does, yeah.
Nice.
Yeah, that's pretty much it on GitHub on your own. I do recommend use it in the context of a wider archiving and backup strategy, as Steve described. Open Science Framework is great for that purpose, but that's pretty much okay. What you should do to use it on your own. If you're working with other people, I do recommend looking at tutorials for forking, which means copying someone else's repo on your own account, and to deepen your understanding of what committing and versioning and branching is, because that's what gets you a long way.
Thank you very much. Charlie, you have questions?
I saw on GitHub there was a little green and red. It looked like people had liked the project, like +17, -5.
No, those are the lines added or deleted
from an individual.
from an individual.
Gotcha.
But people can comment on every commit and like or approve or comment. If someone is really, really tagging you on while you write, they can comment on the specific function you're working on and add suggestions or critiques.
Great.
Doesn't happen often to me. Like, I work mostly on my own, and when I'm in a good moment, there is in GitHub, we didn't see that, but there is in GitHub the option to do an official release, which is not indifferent from a commit, except that it's tagged differently, so that you can point people to download version 1.2 instead of commit 64 digits of code of that commit specifically. And that are maybe more subject to comments and suggestion from the audience if you share the code.
So related to Francisco's question about not storing data on GitHub, that doesn't mean you can't version data offline, right? There are tools available that allow you to version a folder and a set of files, like you can with code on GitHub.
Yeah,
right?
yeah. There are tools to do that. GitHub, I would say it's not that one.
Okay.
So if we sum up what the most important tools are in general, which you need for having good documentation and archive your data and your code properly. So what we talked about is, well, first you need to have a tidy folder structure on your own computer, which you can sync with different tools. But then for different tools, it's good practice to use an online repository like Open Science Framework, where you can have a cleaned up version of your project. It's good to have GitHub as a code storage. Then we should have data file storage where we upload all the more or less de-identified raw data so that people can reuse it.
Yeah, and Open Science Framework can be used for that.
Yeah.
All of this is to say, if just generally talking about archiving and keeping things neat, one thing I would reiterate is you do, back up your stuff, back up everything. So GitHub is great for backing up and keeping versions of your code. Open Science Framework is great for versioning everything, and it can be used for backing everything up. But you should also use cloud accounts and hard drives and everything. And if you have a really neat, it all streams from having a really neat, organized local file structure.
Yeah.
But if you can just drag and drop that and save it and sync it, that makes your life way easier.
Yeah. Do you know whether Open Science Framework has limitations on how much you can upload? I'm wondering about fMRI data or very file intense and say.
So I haven't bumped into the Open Science Framework storage limits yet. But one thing that's great is Open Science Framework allows you to link in different. So I showed you that you can link in GitHub, You can also link it to Dropbox, so if you have lots of storage there. And there are other, Open Science Framework tweeted us and tell us what other tools that you can link in. I'm sure there are other ones that I don't know of or haven't used.
Yeah.
So the storage is expandable in that way.
Yeah. And one thing we didn't talk about this today, but I find this really useful. There's Neural World, where you can upload unthresholded fMRI results so that people can look into this without being dependent on your statistical thresholding.
Yeah, there's probably a whole other episode of this show to be done on fMRI
Probably.
data storage and archiving.
Yeah. One last thing about data storing online, de-identifying information. So of course you have to look into your own protocols and what your IAB board says about this. But also apart from face blurring and like for online data, deleting the IP addresses and of course the names and information which can be used to identify, is there anything else to worry about?
It's good policy. We're all in support of open science here, I assume, talking about this. It's good policy to incorporate some of this language in your IRB, just so they know that you're storing certain sets of data, and so that there's an external check that what you're putting online can't be used to identify your subjects. Especially if you're doing human subjects research, that's really important.
Yeah. Okay. So there are no new questions coming up. So thank you very much for watching today. The next session is in 2 weeks. At the moment, it looks very much like we're going to talk about dealing with rejection and frustration. It's still up for votes until next Monday. So under this video, I posted the link where you can vote for new topics, and I hope to see you soon. And thank you very much for helping me hosting the session tonight. This was very helpful. I learned a lot, and I hope everybody else too. Bye.